Alright, so on to practice problem number 4. Just a little heads up on this one. This requires some knowledge from algebra in order to figure out, so if you're in one of the remedial classes, this might not be the biggest help to you, but if you've already gotten through algebra and you're just getting into some word problems and stuff, and you don't quite know how it works, this would be helpful. Or maybe you're in pre-calculus or something like that. So, now that we've gotten that out of the way, let's read our problem. A farmer wants to build a rectangular pen next to a river. He has 480 feet of fencing lying around. He plans to leave the length of the pen next to the river unfenced so his animals can get water. Find the length and width that would maximize area. Okay, so we've read it once at a regular pace. Now let's brush over it with a fine-tooth comb. A farmer wants to build a rectangular pen next to a river. Okay. Something we should have already picked up on the first reading is some vague idea of like what the picture is. So that's all that first sentence is doing, is it's sort of like giving us a picture. He has 480 feet of fencing lying around. So what that means is that all the fencing we're going to have around this rectangular pen is basically going to have a perimeter of 480 feet. So that's what I'm getting from that second sentence. Now the third sentence, he plans to leave the length of the pen next to the river unfenced so his animals can get water. So let's just ignore this bit about his animals getting water. Doesn't seem mathematically relevant to me. So we'll set that aside. What's relevant here is that the length of the pen next to the river doesn't have a fence. So this 480 feet of fencing isn't going to go to that, is only going to go to 3 of the 4 sides. Now last sentence, find the length and width. So that's just telling us what we're looking for. Okay. So now that we've sort of analyzed this and sort of gotten some idea of what sort of stuff we're going to be working on, let's draw a picture. Okay, so I'm just going to start with the river. Okay, that's our river. Good enough. He has 408. Okay. So taking from this third section, we're only going to have fencing here, here, and here, let's say. There we go. Again, doesn't need to be perfect. Okay, so now he wants to leave the length of the pen next to the river unfenced. So this here is going to be the length, and then this is the width of our pen. And we have 480 feet of fencing. This is going to get into the next part where we're looking for relevant equations. So this right here is going to tell us one of our relevant equations if you take a look at the picture. So this length all the way around this fence, the perimeter, if you will, is going to be 480 feet. So what that means is that the sum of all of these is going to be 480. So we have the length, we have the length plus 2 widths, right? 1, 2, is equal to 480. That's what that's telling us. So that's one equation. Now, we can't really solve anything with this, though, that one equation, because if you take a look here, you see that there's nothing, like there's no way to solve for length or width. We need to know one to know the other with just a single equation, and we don't know either, so that's not helping us very much. So let's try and figure out other equations, see if those help us out. we're talking about a rectangle, right? So what's the area of a rectangle? Right? The reason I think of area is because in the last sentence, we're talking about maximizing the area. So that sort of cues in that we might need area here. Now the area of a rectangle is a really simple formula. It's just the length of one side times the width of that side. So length times width. And now we see we have two equations, two unknowns, right? We have length and width, so those are two unknowns. All we need to do now is solve for one of them. Okay, so here's what I'm thinking we do. It's very easy to solve this equation right here for length or width. So I'm just going to solve for length here. If we subtract 2 width from both sides, we're going to get negative 2w plus 480. Right? So the length is equal to negative 2w plus 480. And we can just take this and substitute that in there. So we'll end up with the area is equal to negative 2w plus 480 times width. And if we distribute that width through this problem, what we're going to get is negative 2w squared plus 480w. I sort of ran out of space there. Negative 2w squared plus 480w. There we go. So, we have that right there. Now, this here is the algebra part. If we look closely at that expression for area, what we'll notice is that this is just the formula for a parabola, right? So what I mean by that is if you had y equals ax squared plus bx plus c, this here would be a parabola. Now because we start with a negative 2, what that means is this is a downward facing parabola. And the maximum of a parabola is at the vertex. Right? So, if we find the vertex of a parabola, then that'll give us our maximum. And in this case, this is going to give us the maximum a value. So, all we need to remember is that is the formula for a vertex. So remember that to find the vertex, you just need negative b over 2a. And b is that in front of the x term, and an a is what's in front of x squared. So, knowing all this, let's use that to solve this. Okay, so we have, let me write it one more time for clarity. A is equal to negative 2w squared plus 480w. So, we just need to change a few things here. The width is what's replacing x. So that means we need the b term is in front of w with a single power, and the a term is what's in front of w squared. So, our w is going to be negative b, 480, over 2 times a. A is negative 2. So negative 480 over 2 times negative 2 So negative 480 over negative 4. If we type this in the calculator, we should get 120. So 120 feet is the width. Now we want to find the length. All we need to do is go back to this equation right here. Right? Length is equal to negative 2w plus 480. So I'm going to erase the picture now that we've gotten all our equations and stuff. So we'll do length is equal to negative 2, but we know what the width is now. The width is 120. And then plus 480. All I did was copy that down and plug in 120 there. So 2 times 120 is going to be negative 240 plus 480. Now you do that math, you're going to get the length is 240 feet. Meaning, our final answer is length of, no, let me write it this way. Final answer is 240 feet by 120 feet. That right there would maximize the area. And that is how you would solve a problem like this.